Okay, so in this part of the video, we are going to see how we can, what is the relationship between RTL ASM chart and the RTL code. Okay, so that's what we're going to see. So we have something called the RTL ASM and the RTL code. Okay, so basically here we can see that here is our RTL ASM that we need to know how to generate. If we give the RTL ASM chart, you must know how to get this. If we give you the RTL code, you must know how to get this. Okay, so let's see what's the relationship between the two. So we have already seen this one. In this one, we've seen a little bit in chapter 6, and then this one is in chapter 7. We have seen a little bit. So what is the relationship, and how do we get from an ASM chart into the RTL code? Okay, so let's bring up our notes here, and okay, and let's say we have this, and we want to generate our RTL code. Okay, so how does our RTL code going to look like? Okay, so basically the RTL code is going to start with our state S0, which is this one. Okay, and this is the RTL operation. Okay, so this is your state, this is your operation. Okay, I think it's a little bit messy there. Let's see if we can remove this a little bit. Okay, so it's quite simple. So basically say that in state S0, we are going to transfer the content of A into register M. Okay, that's all we do. Okay, and then in S1, okay, after we finish S0, by default we are going to go to the next state, which is S1, and in S1 we're going to transfer like this. In S2 we are going to transfer RM, and then in S3 we are going to do in parallel. Okay, in parallel is going to look something like this. You can do like this, and then we can do M R. Okay, so these two we do in parallel, and then we can go something like go to S0. Okay, so you can do something like this. Okay, this one you can do something like this if you want. Okay, so this is the RTL code. So given the ASM chart, you need to be able to know how to define or how to derive the RTL code. Okay, now given RTL code, can we derive the RTL ASM chart? Okay, so that one I believe it should be the next example. Let's have a look at this one. Okay, so this one is a little bit more complex, and let's see how we can derive our RTL ASM chart. Okay, RTL ASM chart. Okay, so we have seen already we are in so normally we do a reset, and then we are going to start with the state called SA. Okay, reset. So what is the operation that we are going to do in state SA? Okay, so state SA, this is what we want to do. But this one, if P equals to 1, we do this. If P equals to 0, we do this. So it's basically a melee type of output, where we are going to check our P. Okay, we're going to check our P. So if P, okay, I guess we can do something like this. Okay. Okay, so if P is put 0 here and 1 here. So if P is 0, we are going to transfer A B star, which is the invert of B. Okay. Else, if P equals to 1, we're going to transfer A into B. Okay, so this is exactly what you do there. Alright, so once we finish with SA, we are going to go to state SB, and in state SB we are going to, okay, so we have a SB state. Okay, so it doesn't matter there. So what's going to happen is we are going to go state SB. Okay, so in state SB we are going to check P and Q. Okay, so if P is equals to 0, let's put my 0 here. Okay, so if P equals to 0, we are going to put A into 0. Okay. Oh, sorry, this is P equals to 1. Okay. So here is P equals to 1. We're going to transfer, okay, A into 0. If P and Q, so if P and Q, so we're going to check Q. Let me see here. Okay, so okay, sorry, just need to quickly. Okay, so I guess it should be something like this. So P and Q, put 1 there. So P is 1, Q is 1. Then we're going to do A star. Okay, and then we go to the SC state. So we have room here. It's our SC state. Okay, something similar like this. Okay, so again, this is quite tricky. This one is quite tricky. So here in SB, okay, in SB, we're going to check our P. Is it 1 or 0? If it's 0, then we just go to the next state. Okay, if it's 0, we just go to the next state. If it's a 1, then we are going to set A to 0. And then we're going to check P and Q. So if both are 1, so P is 1, Q is 1, then we are going to set also our A equals to A star. Okay, if it's 0, then it goes back to SC. Okay, so in SC, we need room here. Okay, so let's continue up here. So SC is like this. So okay, so in SC we're going to set done equals to 1. So done equals to 1, it goes inside. Does not depend on any of our inputs. And then we're going to check our Q. Okay, so if Q is 1, then we are going to do B to A. Okay, and if it's 0, we are going to do B A minus B. Okay, and finally it goes back to let's see, can we like this all the way up there. Okay, it goes back to SA here on the last one. Okay, so let's look at this again. So basically you say that in SC, okay, done equals to 1. Okay, we put it inside the more output, and then we check our Q. If Q is 1, then we do this. If Q is 0, then we do this. After that, you go back to state SA. Okay, so basically that's it. That's how we do the that's how we convert actually. Okay, from ASM chart, RTL ASM chart, and the RTL code. And I think there should be one interesting example here. Let's try and derive the RTL code from this figure 72C. Let's do one more. Okay, so RTL code. Okay, so how many states do we have? We have 6 states. Okay, so we have here we have state 0, state 1, 2, 3, 4, 5. Okay, so the first thing you need to do is you need to define the states. And what happened in state 0? And first of all, you see the more output. So you can say done equals to 0, like this. Then we do the start. Okay, so just check the start like this in bracket. So what happens if start is 1? What happens if start is 0? So if start is 1, then we are going to do concurrent operation. Okay, it means in parallel we do X, and we also do R3Y, which is these two together, okay, when start is 1. However, if start is 0, then okay, so I guess you can do something like this. I prefer to do something like this. You can also do let's see, go to S1, and then you can also do something like this. If start is 0, then we want to go to S0. Okay, so let's look at this again. So basically, if start is 1, we do the RTL, and then we go to state S1, the next state. Okay, if start is 0, we don't do any RTL operation. Okay, start is 0, we don't do any RTL, we just go back to state S0. Okay, so what happened in state S1? So in state S1, we're gonna have the RTL operations, okay, which is just these two. So you can just say R1 left shift 1, R2 R1 times R1, okay, S2, okay, by default we are going to go to the next state, which is state S2. So in S2, again, no issue there, so R3 divided by 3. S3, also no issue there. Okay, so this one done. S3 is R3 divided by R2. S4, R1 divided by 3. Okay, and then S5 is a little bit different, a bit tricky there. Okay, let's see what happened in S5. So in S5, we have a more output, R1 minus R2, and we also have done equals to 1. Okay, and then you're going to check the start. If start is 1, so if start is 1, then we are going to go back to state S5. However, if start is 0, you can do something like this, and then we can go back to, we need to go back to state S0. Okay, so I think that's it. We have done with the state machine there, and we have generated our RTL code. Okay. Okay, so I think this is complete with this part of the lecture. I think for the next one we will go through the next part, which is on the bus implementation for RTL.